welcome. Let's go through the first presentation of Outotec, that how can we make our concentrator more environmental friendly. And this is a kind of upcoming trend, which is absolutely affecting all the mines in Scandinavia, and of course a little bit outside also. Number one issue which has happened lately is that instead of just thinking about the business constitution where you are generating money from the ores what you are digging, there is two other kind of things that you have to kind of look for. Number one is the license to operate, and the second one is the brand value, what you can do if you destroy the environmental issues. And a good example is this San Marcos Valley tailings dam failure 3 years ago. First estimate was the cost of repairment of that one was in between 5 and 6 billion US dollars. But after they started to look at what is the cost of the license to operate for them, when they have to clean everything, what they have spoiled down, they have to repair the dams, etc., and they have to kind of get the socio-political acceptance from the neighborhoods. This started to increase, and of course, if you look at what was the brand value of the stock came down extremely much. That basically ended up that the final sum of was 43 billion US dollars. So over 10 times more than first estimate. And this has now resulted that whole South American mines has been starting to think in, it's not only the business constitution, but you have to also to understand the license to operate and the brand value. And this is reviewed 2 times per year on all of these sites. Okay, so what does it kind of basically mean? If you think about water issues and tailings issue, they are extremely tightly connected to each other. And if you have a kind of simple risk matrix where you are looking at what is the possible risk value, kilo euros to billion euros, and what's the probability of something to happen. And you pull it against conventional tailings dam, you are looking at the paste, and you are looking at the filter or dry stacking. It is quite simple to see. If you look at the dam wall breakage, pollution of both surface, groundwater, socio-political risk, image risk, water shortage, and risk of total operation, you can see that mainly all of these ones, conventional, are at high risk areas. Much less than the paste, much less than the dry stacking. So it's from that point of view, it gives you better possibility to avoid socio-political issues and big dam failures. Another issue what you have to understand is that when you talk about the water and you talk about the operation of this process which is here, you should not just focus on here, because the water is collected from much bigger area, and to understand that what is happening, you have to calculate the whole site area, how much are you going to have water there, and in which place. So I have been making very simple mass balance calculation, which is basically telling you that what is going to happen if you close up the loops with a different kind of tailings methods. And this is a quite simple one. It's for 20 million tons per year. It's a copper concentrator located in temperate zone on the eastern side of Finland. And you can see that you have the fresh water, you have the concentrator water, you have the tailings area, you have the return of the tailings area, and then you have the major kind of water captures. What does it mean is that if you are trying to pull 20 million tons of ore through this one, you need to have something like 1,200 cubic meters per hour to counterwind what you are losing from the tailings dam point of view. And there is a couple of things which are of interest. Number one is the amount of wastewater what you are generating. This is something that you are not able to capture. You can only capture about 100 cubic meters of the total one that you are losing. The rest, it's going to end up as a effluent. And you know that when you are kind of putting such a kind of system up, this is the one which is going to cost you now extremely much. And that's depending on the environmental limits of the countries. And these are not going to be lighter. They are just going to becoming more stricter, which meaning that you have to basically go down to clean the water to ion levels. That will cost a fortune. And beside of that one, you have the whole tailings area, which is basically a chemibiological reactor, which is going to change the water quality, what you need at the concentrator plant. So what is happening is then that if you are using a thickened tailings dam, thickening tailings, it means that most of the water is going to recycle much earlier, meaning less water to the tailings area, meaning that you can also reduce a little bit about the wastewater amount, which is a benefit, but rest of the balance is the same. And of course that means that the freshwater amount will be less. If you are then looking at going over to a paste one, here you can see already that the tailings dam has been, the size of it has been basically reduced to half. And the good point is that the amount of effluent is now very low. It basically doesn't exist. This is only when you have some snow melting or storm water, when you expect to have some kind of water treatment. But from that point of benefit, this starts to look good. Of course, it means that you have now a much bigger flow going around in the central of your concentrator plant. What is another benefit is here is that you remember that this is restricted by the environmental people who are saying that what is the type of water you have to have. That's still an expense. When you think about then this side, you don't have to talk with the other ones. It's only your own company who is kind of looking at this one. The blue dot here is that, meaning that, of course, you have to start to look for something else to clean up the water loops. But absolutely, it will not be similar to that with what you are going to find here. Okay? Now you have been reducing the freshwater need from 1,400 to a little bit less than 1,000. You go one step further. And you can see, now you are starting to talk about that how little amount of water are you now using. And basically your tailings area is only 20% of the original one. That's dry stacking. Now all the water is going around here. And of course we have to think about that, what do we have to do with that one. But basically running once through it, you can see that how it's affecting the tailings area and the water balance. So this is the story of today. Then when you start to think about what's the effect of this loop going back to the concentrator, and you are looking at which are the harmful components what you have to start to look for. As an example, if you look at porphyric copper ore, iron ore, or gold ore, you will have lots of kind of stuff that you have to kind of put your eye on. And especially on copper one, you have to look for sulfur species. If they are going too high up, you are going to reduce your recovery and also your quality of the ore. Iron ore, reverse flotation, it's a big issue. We have to come to that later. And of course, when you talk about gold one, you are talking about fines, and you are also looking at the sulfate. And this is what typically happens. So if you have an original graph XY where you have lots of the freshwater usage, totally open system, and how amount of process disturbance what you are going to get in your process by connecting it again, you can see that as long as you are very open, there is not so much of problems. You are mainly kind of talking about fines. But the more you start to close, there are compounds which start to stick up, and those are going to harm your recoveries and qualities. And of course, the general operation of the plant, as you know, you should be always looking at the pH, conductivity, temperature, and redox. Those are not going to be stable. The more you close, the more those are going to be unstable if you don't know what you do, which is also resulting in not so profitable operation. Couple of good examples from a Finnish site here. You are talking about water qualities in a polymetallic ore. You can see that as many of the people at the site are telling that all the process water are stable and they are very good quality. That's not true. And they are jumping like hell. So just kind of checking that how is the effect of the copper grade or nickel grade affected by different types of water that you are either having during the season or then the qualities, and you can see that how much is better improved versus getting worse one if you don't know what kind of stuff you are utilizing in the flotation. This is another one, it's going on. I will jump it over. But for that one, Outotec has been kind of building these kind of water treatment plants, kind of kidneys that you can put in your main process streams to remove all those main components what you should be taking away when you think about flotation performance. And another good thing that we have in Outotec for this one, we are using the HOASS sim for it. So whatever you are going to do, it's always best to kind of simulate your process first and think about that, what are the main components, what should be taken away and where it should be taken away. And then we have been even going one step further, because I know that many of the sites doesn't even know what type of water they have or quality of the water. So we have our own system which is called VQQM, where basically you are touching the whole site water balance. And it's online, so it's measuring all the main parameters and of course calculating the mass balances where it's going. And you can drill yourself down all the way and see that how much are you now utilizing water, how much is in the effluent, what is the meaning of the concentrator plant, and then on top of that one, of course, you can use it for reporting purposes for both authorities or then for your own mill personnel. So, going very fast down to this, you know that water scarcity is the driver, and that would be also, and it's not always the scarcity, but the issue is that the more you take water in, the more bigger problem you have of possible water failures. So try to go away from that one. And you have to do it with the right kind of tailings management. That's absolutely the way how it's going in the Nordic countries. There is no other alternative for the mining than go for these more closed water loops, because nobody can afford to treat the huge amount of water that you are today using. It will give you a better socio-political acceptance. It is much easier for you to focus on the internal water treatment instead of external one. And the benefit is that whenever you are cleaning a process water, it doesn't need to have the same quality as you are doing on the effluent one. So, basically, whenever you are countering this one, always remember that the process water has a big impact on the quality what you are making. So by this one, I'm really kind of saying that I like this statement always. If you always do what you always done, you always get what you always did. So you have to kind of start to think in a different way. So, thank you very much.